Okay, good morning all, and welcome to this webinar. Thank you for all for joining us. Today we're going to deal with a webinar on net zero carbon in construction, and it is a joint effort between the Buildoffsite network and the Driving Net Zero Carbon community practice, both of which are run from within CIRIA. My name is Andy Moores. I'm the Director of Research at CIRIA. Those of you that were expecting Dirk Venix, who's our CEO, I am a late replacement. Unfortunately, Dirk has come down with COVID this morning. So hopefully between myself and the other people on the panel, we can make this a very worthwhile experience. Just a bit of housekeeping. So all of you that are listening in, the webinar is being recorded. You're in listen-only mode. If you do want to raise any questions or you're having any problem with the technology, please just jot that down in the chat. One of our helpers in the background will get back to you and hopefully be able to resolve your issues. If you do see questions that somebody else is asking within the Q&A box, please just like those with the thumbs up button, because it allows our moderators to identify those questions that are the most popular. And obviously helps to filter those for the Q&A session, which we're going to have at the end. If you're of a social media persuasion, please share your views on the @Buildoffsite and @CIRIA Updates Twitter handles with the hashtags net zero carbon, sustainable construction and offsite construction. Bear with me, a little bit of lag. Okay, so just by way of introduction to CIRIA itself. So CIRIA is the Construction Industry Research and Information Association. We're a member-based not-for-profit organisation, and we aim to work collaboratively across the built environment structure to be the leading provider of knowledge aimed at improving performance. We essentially sit at the interface between research and practice. Our guidance is widely used, and we pride ourselves on our independence as well as the quality of our outputs in terms of taking things from research into practice. We also produce high quality training courses and webinars with the aim of encouraging knowledge sharing across the sector. Our members are various. Just waiting for the slide, and are drawn from a range of government departments, key client organisations such as Network Rail, Highways England, and the utilities sector. We've also got members from the Tier 1 contractors and consultants, the wider supply chain, and also increasingly from the academic sector, where we're trying to help broker knowledge between academia and industry. If you do want to get involved, please do get in touch. We're always open to discussing new membership. So CIRIA runs a suite of communities of practice, of which the Driving Net Zero Carbon is one of those. And we also have communities of practice across different areas of the built environment sector, most notably perhaps sustain, which is becoming increasingly important given the introduction of Schedule 3 of the Floods and Water Management Act and the implementation of SUDs within new development. We also have work on biodiversity interest group, including an award ceremony, really looking at how we can deliver multiple benefits across built environment, including biodiversity net gain. And you may notice within the bottom right there, NEMO, which is the new name for the BIM Alliance. They've recently rebranded, and CIRIA provides a home, if you like, to that particular network. So the Driving Net Zero Carbon community of practice really shares those generic aims of our communities of practice, looking to share knowledge, stimulate debate and foster collaboration. As you're well aware, it's a very, very busy space at the moment, and we're really trying to encourage that knowledge sharing between different sectors to start to distill good practice from what's going on. This is, well, rather in 21-22, we had a series of webinars which are outlined there around reducing Scope 3 carbon in the supply chain, incentivising carbon reduction in the tender process, which was led principally by a combination of DEFRA and the Environment Agency and one of their key suppliers, WSP. And we also had one on de-risking alternative low carbon approaches. All of those slide decks from those and indeed the webinar recordings are available via our website. We're moving on to this year. We've had a webinar last week on timber construction for reduced carbon. Today, we're going to be tackling net zero carbon in construction. And we're in the process of putting together a webinar on carbon tracking and calculating, which we're aiming for a February 23 date, and a low carbon concrete next steps webinar, really building on some of the work that was done with the low carbon concrete route map and the work streams that have stemmed from that. At the moment earmarked for April 23. So please keep your eyes and ears peeled for more information on those series. It just remains for me to thank the Net Zero Carbon Community of Practices, sponsored by a combination of BEIS, the Environment Agency, National Highways, Thames Water, WSP and Zero Waste Scotland. We are very grateful to their sponsorship of this series. And if you do want to get involved, please, again, do get in touch.
Thank you, Andrew.
Okay, it just remains for me to introduce Nigel Fraser, who's an independent consultant, but has been working with us for a number of years on Buildoffsite, who's going to give a brief introduction to the Buildoffsite initiative. Nigel, over to you.
Thanks, Andy. Yes, Buildoffsite has been established for some time now. Could I have the next slide? Offsite industry, and it's sought to promote and support and increase the adoption of offsite and pre-manufactured solutions in the built environment. And we work collaboratively with a number of members and aim to influence government and key industry stakeholders to facilitate the use of offsite, so that we can deliver that through improving the guidance and highlighting the sort of benefits that can be derived from using offsite. By normalising modern methods of construction, Buildoffsite enables greater project delivery and strives to remove the perceived challenges to offsite adoption, and we're doing quite a bit on that at the moment. So our aim is to be the trusted independent voice of the construction industry with respect to offsite and pre-manufacturing, and provide all relevant support to our members and other stakeholders. Next slide, please. So, as with CIRIA, we've got a broad membership base of approximately 60 members, and they cover everybody from client organisations, academia, designers, contractors, manufacturers, specialist consultancies, and material suppliers. So, a very wide church, cutting right across the industry. Next slide, please. So, we've got quite a track record in producing guidance documentation on a number of subjects. Some of the recent ones have included a collaboration with Cambridge University on developing a methodology for quantifying the benefits of offsite construction. Just before the pandemic hit us, we produced a linear infrastructure overbuild guide, which sort of built actually on a report from WSP called Out of Thin Air, where it was identified that there were actually quite a lot of opportunities to build residential units above rail lines in and around London, and we took a wider view of that on linear infrastructure in general, and we'll be having a follow-up event probably in February on that. During COVID, we actually saw a lot of changes in how people were working and how the design process was evolving, and we did some research on that, and again have published some guidance on how some of the lessons learned can be used to carry things forward and maintain that progress. Next slide, please. There's also been a review of how the offsite sector has responded to COVID, and also what we can do to help with the proposed, well, the current policy in terms of the government's construction playbook. And we've also done collaborative research on what are the challenges and barriers to the adoption and implementation of offsite and MMC, which again is quite an informative report that members would find useful. Next slide, please. We're currently in the process of discussing and reviewing two such reports. The one on the right, Achieving Sustainable Resilience in New Precast Concrete Structures, is actually something that we're going to talk about in this webinar, so I won't go into too much detail on that, but that is now published. And we have a offsite construction concept design and delivery report, which is about to go out to peer review, and we held a launch event on that at the end of last month, so that's very close to publication. In the pipeline, we've got a couple of activities focused around the client group. One looking at how to specify for performance so that we can include a whole range of delivery options, including offsite, and also a more detailed look at IP management and how to make sure that when people are and organizations are collaborating, things can be brought to market and exploited in an equitable way for those involved. We also regularly contribute to the supply chain sustainability school projects, the most recent being the social value project, and we've been working with the CIH as a dissemination partner with respect to things like the platform guides, and also an input to the transport and logistics side of things. So we've been quite busy. Next slide, please. The Achieving Sustainable Resilience in New Precast Concrete Structures that we're going to be talking about shortly has been a collaborative production, including Mott MacDonald, C-Probe, Structural Healthcare, and others. And it's free to download from the Buildoffsite publications website for members. For CIRIA members, it's available at £50, and for non-members, 100. So that's all information available on our websites. But I'm sure you'll find it's an extremely good value for money. Could you please advance next slide? So today's webinar is going to be chaired by Dr. Kat Ibsen from WSP. I'd like to invite Kat to take the reins at this point. Thank you.
Thank you, Nigel, and welcome everybody. So the built environment generates 30% of total greenhouse gas emissions, and construction uses 32% of the world's natural resources. So as the biggest contributor to climate change, recognise that the construction industry has the greatest opportunity and responsibility to reduce emissions. Now, in this webinar, we will explore how the construction sector is innovating to support the net zero transition, and how offsite can help deliver environmental, social and governance targets, ESG targets, to improve sustainability within the built environment. As attendees, you will hear firsthand from the authors of the Buildoffsite's new guidance, Achieving Sustainable Resilience in New Precast Concrete Structures, and you will learn from a practical case study on net zero construction. You will also discover tools to measure carbon emissions within the supply chain. So as you'll see, you can move on to the next slide, please. We have a great lineup in terms of subjects, and we'll close off in terms of a Q&A at the end. So with no further delay, I'm delighted to be joined by our speakers. We have Dr. Chris Atkins, a technical principal within Materials and Corrosion Technology at Mott MacDonald, Graham Jones, Managing Director at C-Probe Systems, Mark Graham, Business Development Director, Net Zero Buildings, Neil Pennell, Head of Design, Innovation and Property Solutions at Landsec, Ian Heptonstall, Director, Supply Chain Sustainability School. And as you've just heard, Nigel Fraser, who's our Industry Advisor at Buildoffsite. So let's begin with our first presentation by Dr. Chris Atkins and Graham Jones, the authors of the Buildoffsite's new guidance on achieving sustainable resilience in new precast concrete structures. We'll post their biographies in the chat, but over to you, Chris and Graham.
Thanks, Kat. This is Chris Atkins. I'm going to cover the first probably 5 minutes of the presentation, which apparently was due to start 10 minutes ago, but you know, such is life. And then I'll hand over to Graham to talk about alkali activated cementitious materials. What we're here to talk about is the latest publication from Buildoffsite that's achieving sustainable resilience in new precast concrete. Offsite, both sustainable and resilient. And we're going to talk about a bit about how we got there. So the document itself identifies different materials you can be using to try and reduce the initial carbon footprint of precast concrete. It discusses how to make structures durable and what we've found to be the problem historically with concrete structures. We're looking at whole life economic carbon issues arising from extending the service life, because it's all well and good saying we want a 50-year life out of this, but at 50 years, they then typically want another 10 or another 20. And we're looking at structural health monitoring and control. Firstly, a bit about embodied carbon. A lot of people talk about it. There's carbon figures bandied around all over the place, but it can sometimes be missed as to what it actually is. So when you make something, anything at all, you use energy, and the more complicated it is to make, the more energy you use. Most of that energy comes from burning fossil fuels. When you burn fossil fuels, you release carbon dioxide and water. The fossil fuel itself is a long-term carbon store. So all this carbon dioxide is extra carbon dioxide that's reintroduced back from dinosaur times when it was nicely locked away as oil and gas. We then make something, it's processed and transported to where it's going to be used. That uses more carbon dioxide. In addition to the fuel that we use, the tricky thing about cement, Portland cement, is we burn limestone, and that physically releases carbon dioxide as part of the process. So that's one of the reasons cement is seen as positively evil from the point of view of greenhouse gases. As an example, if you take a linear metre long column that's 250 by 250, include the reinforcements, kind of 40 years ago, we'd be using straight ordinary Portland cement mixes, well, actually probably 60 years ago, and that would be 77 kilograms of carbon dioxide equivalent per linear metre of column. If we take 30% of the cement and replace it with pulverised fly ash, that's a waste industrial product from burning coal, we got that down to 56 kilograms. And if we use 70% ground granulated blast furnace slag, we get that down to 35 kilograms. Now, both PFA and slags have been used for probably 40 years as cement replacements. They both come from sources that aren't really renewable. One's from burning coal, one's from making steel in blast furnaces. So that the supply isn't infinite. And then when the steel starts to rust or the concrete falls off, all that energy we've invested in producing the structure, we are basically just throwing it away. The other problem with corrosion is that it's a perfectly natural phenomenon. Steel doesn't want to be steel. We stuck a lot of energy in it to make it steel, and it wants to turn back to rust. When it rusts, concrete falls off. We also lose structural properties. We lose section. So as well as the bits of concrete falling on people, we're losing structural capacity. As Kat mentioned, 7 to 8% of carbon dioxide emissions in the world are the result of Portland cement production. Now that's an appalling amount, but if you look at the actual use of cement by mass, 52% of the stuff used in the world is concrete. So it's not so much that cement is bad, it's just we're building a lot of stuff. 70% of the damage on infrastructure is due to corrosion. And sometimes, if you let it corrode and don't keep an eye on it, really bad things happen. So this is the condo that collapsed in Miami in 2021. Repairs are about to happen. It's all very well sitting there and pointing at going, yeah, but that was America. We're different over here. No, we have collapses over here too, due to corrosion. So we need to make durability better. And the conventional approach to making more durable structures so that we don't waste all the energy we've invested is to stick more cover onto the concrete or more cement into it. Both of those just mean more carbon dioxide, and it's been the historical approach that's been undertaken, and that has led to a significant industry repairing it. So it's not entirely perfectly reliable. One of the things we do to steel all the time to stop it rusting is coat it, but we tend not to do it to concrete. And we can work out the figures for coating concrete. So it's about 2.7 kilograms of carbon dioxide per square metre per application. And we might need to do it again and again. The difference is with concrete, with steel, when the coating falls off, it starts corroding instantly. With concrete, when the coating falls off, you've still got a protective barrier of concrete. So you can sort of plan your maintenance based on what's actually happening. Graham's going to talk in more detail about cathodic protection. There's a range of options. We can either make it easier to cathodically protect in the future. So that's join all the steel together and make sure it's all electrically continuous. That means we're going to have no additional CO2 until it's needed. We can include anodes and monitoring so that we're monitoring it to see when the corrosion started, and we can turn it on when the corrosion started. That's about 3 kilograms of carbon dioxide per square metre, plus the power supply when we need it. But these are all extra low voltage, tiny current systems. Or we can stick cathodic protection on at day one. That uses lower current to prevent corrosion, then to stop it once it's started. And as their alternatives to achieving durability, the alternative to using Portland cement is the use of alkali activated cementitious materials, and Graham's going to take it over from here.
Hello everybody. I'm not sure I've got control of the screen. I'm seeing Sean's screen. So Sean, can you move on in a second? Just let me dwell on this. The guide does focus a little on alkali activated cementitious materials as an option for low carbon cement binders. That doesn't mean to say that other efforts are not out there trying to lower that carbon, as Chris outlined. But the use of AACMs use an awful lot of the secondary cementitious materials. And what I want to try and focus on here is how we've used these materials to focus in on the resilience aspects of construction. What I would add, though, is the evolution of this PAS 8820 in 2016 has seen the formation of the Association of Alkali Activated Cementitious Materials, or A3CM, which I'm a founding director. And that organisation is currently focused on drafting engineering specifications for using these materials, which we hope to distribute to the industry next year. One case study, this is actually in restoration, not in precast, but the principle is the same. As Chris alluded to, if we allow steel to corrode, we're losing all the embodied carbon that's within that structure if it reaches demolition. And this case study is a current job of Sea Probes in New York, where we're doing in conjunction with Mont McDonald. It is made up of 3 podiums to support a parking structure, some apartments, multiplex cinema, etc. And it was allowed to degrade over time, not probably by choice, but just by budget. And that led to about 40,000 square meters of podium decks, losing 18,500 square meters to concrete degradation. That is all lost. That has to be taken away. It has to be repaired. And our role in this is to provide cathodic protection to protect the whole of the 40,000 square meters. And Mont McDonald have been busy on the design of that. What that leads to, if we use the Institute of Structural Engineers figures of 430 kilograms of CO2 emissions per cubic meter of concrete, and if I omit for the moment the steel replacements to the 18,500, because that is a current assessment that's ongoing on site right now. When they open up the concrete, we'll see what additional steel needs to be attached. So some of these figures will be adjusted accordingly in the future. Well, that leads to a loss of, we calculate, 3.9 kilotons of CO2e on that 18,500 square meters. If we add in then the ICCP to save the other 5.5 kilotons of CO2e, adding in the new materials to preserve and repair the decks means that over the course of the future, when we don't return to disrepair on the structure, then we're preserving embodied carbon to the tune of 10.3 kilotons of CO2e. And the good thing about cathodic protection systems is you get data. It's part of the ISO 12696, which is now 2022 version. And we can design in these systems in order to be remotely controlled. That's fed from that decision making from the data that's achieved. So performance is assured into the future for decades to come. So if you like, it touches all sorts of buzzwords at the moment of prop tech and infratech and insurtech, etc. With clean tech technology, if you're taking industrial wastes, repackaging them as a clever, smart binder in order to be able to pass current through it. So we can automate, streamline, and take the building or the structure, piece of infrastructure, and build that to last with some resilience into the future. The upshot of this, and these are not CPROB's figures, these come from the NACE Impact Report in 2016, the use of control systems saved approximately about 3.4% of GDP of a Western industrialized nation. So it's not insignificant. To give that some US terminology, Congress has just put out $1.2 trillion worth of infrastructure spend, and they can actually save $850 billion per annum by adopting control systems. So not surprisingly, in July last year, Congress announced a $200 billion spend just on control systems of infrastructure. So the market has just improved. Oops, went too far. And this actually has an ESG impact. Kat alluded to this earlier on too. There are big gains in the net zero landscape for ESG impact. And in the case of adding cathodic protection from day one, then environmentally we're repurposing all these industrial wastes in order to produce components that allow us to integrate into the structure and take control from day one. So environmentally a very useful thing to do. Socially, that degradation that doesn't happen then because you're controlling it. There's no transportation disruption, there's no rail disruption. People's days can carry on more normalized by not having to revisit the structure to then have to repair in the future. And it also reduces the use of future resources. We're not having to take concrete away to waste that embodied carbon to then replace it with new materials because we're looking after what we've done from day one. And in the governance sense, we're applying international standards, we're producing performance data, reporting that, tracking that on embedded networks and remotely. And really the good news for owners and for the taxpayer is that that asset value is assured by taking that control. My voice continuing on this, we actually have a little video of the modular anode unit, which is a componentized version of an anode that can be inserted straight into or connected straight into the rebar during construction and allow us to control from day one. So let me just run this.
Most structures are still made from concrete and steel, which leads to CO2 emissions. Climate change is currently a huge threat to the built environment, causing high temperatures which accelerate carbonation and corrosion to reinforced concrete infrastructure. CIRIA is addressing the challenges of raising the resilience of reinforced concrete with its new low-carbon technology, the LOSEM Modular Anode Unit. What is the LOSEM Modular Anode Unit, or MAU? It's a factory-made, moulded, impressed current cathodic protection component that can be attached in an array directly to steel reinforcement prior to pouring the concrete. It is installed as a plug-and-play system with tailored current densities providing long-term sustainable structural resilience and control over steel corrosion. Easy to install. All new construction where reinforcement steel needs protection from future environmental impact. The MAU can be push-fitted to a range of steel diameters during steel construction. Plug and play. Wiring between the MAU is also modular and simplifies the electrical installation. This wiring is routed to zonal enclosure, with the network routed between enclosures to the network access unit for communication and control of protection current. Routing to the interconnecting modular wiring can be made at the precast factory in box-outs and completed after delivery to site, minimizing time to completion of the installation. Protection from day one. When coupled with CIRIA's sustainable resilience management networks, the MAU is easily monitored and remotely controlled online. CIRIA's Achilles Interactive Management Server, or AIMS, takes the data and offers clear reporting for your structure's performance now and into the future, offering peace of mind and added value from controlling the service life for its whole life.
So I think our closing message really is to think a little differently in decarbonising for whole life of structures. The Sustainable Resilience document is the first step to try to inform on that path, repurposing industrial waste, securing embodied carbon, and providing not just sustainability, but future-proofing structures into the future to make them resilient. And thank you for your time.
Thank you very much, Chris and Graham. There's a lot to take in there. So just to confirm, all presentations and a recording of the webinar will be uploaded to the CIRIA website, and a link to this page will be sent to you. So please keep your questions coming, and we'll pick them up in the discussion shortly. And remember to click a thumbs up on other attendees' questions as they're raised to help us identify the most popular ones that are coming through. We're now going to hear from Mark Graham, who's the Business Development Director at Net Zero Buildings, and Mark will talk about improving the sustainability of the built environment with ESG. Over to you, Mark.
Thank you, Kat. Just waiting for the screen to flick across there. Good morning, everybody. Hope you're all well. I work for Net Zero Buildings. I'd just quickly like to discuss and point out how we sit in the group. So we're part of the Premier Modular Group, which consists of Premier Modular and Net Zero Buildings. Premier Modular is a sister company that offers a permanent and a hire solution, while Net Zero Buildings offers a volumetric and a panelized solution into education, healthcare, retail, all the sectors you'd imagine from a company of our size. Our capacity to deliver, we have two factories, one in Yorkshire, one down in Cambridge. In total, 10,500 square meters of purpose-built manufacturing facilities, the largest being in Brands Burton in Yorkshire, which consists of 5 factories on a 24-acre site. Combined, we can manufacture in excess of 100,000 square meters of building in a single shift. During the recent COVID pandemic, we were able to increase to 3 shifts, which is a day shift, evening shift, and weekend shift, which increased that number significantly. We turn over about £130 million per year across the two businesses, and at the heart of what we do is quality, sustainability, and safety. Again, we offer volumetric and panelized system. A volumetric system is a steel frame box, which can achieve up to in excess of 85% PMV, and a panelized system is a closed panel SIP system used as a wraparound. So volumetric tends to be a larger fit out, whereas the panel system tends to be more of a traditional focus on site. So I work for the sister company Net Zero Buildings. Who are we and what we do? Well, we offer a turnkey solution above ground, and we manufacture bespoke systems. We take projects from REBA stage 0 all the way through to handover. As I say, bespoke systems and a product offering zero carbon in construction and operation, using lean manufacturing, high quality performance and efficiency. We work with independent architects throughout the UK and consultants to achieve the best possible project solution for our clients. Again, sustainability, zero carbon is at the heart of everything we do. We truly believe that we can all achieve zero carbon. So just moving on to ESG and a little bit of a recap. So ESG, environment, social and governance, represents a set of standards for a company to be socially and ethically conscious. For ourselves, environmentally, how a company impacts or supports the world it operates in. Socially, how we can interact with employees, suppliers, customers, and the communities around us. And how we can govern our business in an ethical and inclusive way. For Net Zero Buildings and Premier Modular, we wanted to set out a purpose, a reason for achieving ESG. We came up with this purpose to enable a better tomorrow every day for generations to come. This articulates how, as a group, we make it possible for our people, customers, communities to thrive. We came up with a family pact. As a family, we created pride in all we do, agility to have all the tools to create buildings for today and the future, challenge, never stand still, always ask why and what can we do better, and together the sum of its parts is greater than the whole. So specifically, the Premier Modular Group looked at key areas. Now, ESG is a vast array of opportunities and developments within any business and outside. These are just some of the key areas. Given the time that we've got, I'll just focus on a few, but I'm happy to go into more detail later on. Either drop me an email or link in with myself. So as a group, we worked on the following. Implemented this year is reduction in carbon emission and waste management. We installed photovoltaics across all of our factories and buildings, looked to make them more energy efficient through insulation U values. And we're looking next year to move to fully electric forklift vehicles and hopefully company cars. We're looking to have a deeper understanding of our role as a business, regular training sessions quarterly on commercial topics such as anti-slavery, bribery, diversity, equality, inclusions. These are sent out to every member of the team. They're asked to complete a short video presentation online, answer questions, and then give any feedback. Continue to educate our supply chain. We look to enforce proof of chain of custody, not just where we get our supply chain from or our materials, but where they get them from, ensuring that the chain of custody goes right back to source and all the way through. Drive sustainability. We offer sustainable solutions for all of our projects. Even if a client comes to us and has not got zero carbon on their agenda, we try and help them and find simple, cost-effective ways to achieve a zero carbon solution. At the end of this process, we focused on 3 core essentials: the people, the process, and the product. This has taken us 12 months to achieve, and there are many other areas that we've looked at and diversified as well. The culmination of this was that back into 2021, we achieved the SGS ESG accreditation. We believe we're the first company in the UK to achieve this, and maybe Europe. So that's ESG within Premier Group. I just wanted to show you some of the zero carbon in reality. This is Treetops, a DFE Pathfinder school. It's zero carbon and was handed over last month. In order to achieve these iconic buildings, we had to understand where our baseline sat. So we took our standard building and working with AESG, we came up with a series of building envelope criteria to achieve a building zero carbon model. This is backed up with energy efficient M&E and renewables. As you can see, and I won't go through all of this in fine detail, happy to do so at a later date. You can see the U values, floor values that we look to achieve, particularly across air leakage and glazing. Where air leakage is low, U values may increase, but then we can also reduce U values, increase air leakage, giving us the flexibility to achieve what we needed to. So this created a baseline specification. Once we had this, we could then deliver this iconic building. This is the Teddy building in London. It's part of the Canada Water Master Plan and is actually a temporary building. While the steel structure itself has a 60-year design life, it has the building that we delivered for Teddy has a short life requirement of 7 years. It's growable. We can expand on this building and make it larger. And it's flexible to allow delivery in-house of occupants, generated social value and community. But importantly, phase 1 was completed in London and its first cohort took occupation in September 21. Part of the Canada Master Plan is to redevelop this site, and this building will no longer be used. So as a higher building, we are able to deconstruct this building and move it to a new location on site as part of the master plan, reconstruct, and then have new people occupy the building. Key to the client's requirement was circularity. At the end of the 7-year master plan, when the whole area has been developed, this building will be removed, returned to our factory at Brands Burton, and will go back into our hire fleet to be used as classrooms, wards, residential, whatever is required. We feel this is true circularity of use and offered by our hire division. Also unique to this process was the involvement of the students. Our supply chain worked with the students on the equipment used within the building. The students researched and studied the M&E and zero carbon elements used within the building and put it into their thesis and their studies to create a smart city design. Using live data from the BMS in the building, they're now adding this to their coursework in a live environment. A second case study is King's College London. The challenge here was to achieve a reduction in CO2 emissions. Again, we use a fabric first approach, increased efficiency of VRV or VRF systems, replacing radiators with air source heat pumps, heat recovery added to mechanical ventilation spaces, domestic hot water is being provided by a bivalent system, and again, high LED and PV. So I'm not going to go through the technical data. I just wanted to show you some of the results that came from this. Table 1 shows a 41.52% reduction on non-domestic CO2, whereas Table 2 shows the building elements modelled and the percentage of improvement. King's College London is due to be handed over this month, and we'll see more of that on our website as it comes through. So mindful of the time that we have, and I really appreciate all of your time, there are 2 more case studies on my presentation, which I won't go through today, but show how we achieved a zero carbon in construction operation on site. And I'd welcome any further questions at the end of the presentation. But Kat, back over to yourself, and thanks for your time.
Thank you, Mark. I think there's some really interesting information in there, and I would encourage all of our attendees to take a look at the slides post this webinar. So we're now going to go on to our next speaker, Neil Pennell, who's the head of Design, Innovation and Property Solutions at Landsec. And Neil will provide a case study on the Forge, the UK's first net zero carbon commercial development. Over to you, Neil.
Thank you. So good morning, everyone. I think it's just about still morning. See if the slides move. There we go. Okay, so showcasing net zero carbon development and looking at the Forge as a case study specifically is on the agenda for today for me. I thought I'd tell you a little bit about Landsec first. We're one of the UK's leading real estate companies. Our portfolio is in the order of about 12 billion. I think with the stock market recently, it might have gone down a little bit from that in the recent valuations. But essentially 24 million square feet across the UK, central London offices, some major retail destinations, and some mixed-use urban neighbourhoods. And our purpose is creating sustainable places, connecting communities and realising potential. We've demonstrated leadership on sustainability for some time. This is a selection of some of the ratings that we've achieved across a whole series of benchmarks. We like to test ourselves against those benchmarks. Some are required by the investor community, but it's also useful to see where we are both in terms of our progress and where we stand against our peers. Our sustainability focus is on vision around sort of 3 words in the centre of the screen here: build well, live well, act well, reducing operational carbon emissions on our portfolio, and on new construction and major refurbishment, reducing both its operational carbon in use going forward and its embodied carbon to ensure that they don't add further to our existing portfolio's carbon footprint. And we've, in mind of that, we developed a net zero transition investment plan to go back into our existing buildings to decarbonise them over the next few years. We've led on climate resilience within the business because it's a strategic priority for us. It ensures our business remains relevant and creates value over the long term. Obviously, there are risks to the retail sector around the transition period, and there are policy and legal measures in place that we have to comply with, including minimum energy efficiency standards. Performance-based energy ratings schemes are being considered by the government at the moment. We have climate disclosure using the TCFD process for all UK listed companies, as we're a FTSE 100 company. And there's always the potential that carbon will be taxed in the future. It's also important from our position in the market to ensure that we're meeting the aspirations of our customers in terms of setting net zero and science-based targets. In fact, we were the first company to do that in the real estate sector. Our strategy is around 5 steps really, which is reducing the operational carbon in our portfolio, procuring 100% renewable electricity and increasing the amount of renewable electricity we generate on our sites, reducing carbon emissions associated with construction, using internal shadow price of carbon to help inform our decision making around low carbon alternatives, and finally offsetting any remaining carbon that we can't deal with in those other ways associated above. But that's always the last resort. And if we do that, we'll also use gold standard offsets. In terms of new developments, as I said, as we've got a large portfolio, we have a big challenge, and I think that's common to everyone, is that there's estimates that something like 80% of the built environment that we have now will still be with us in 2050, when the government's target for the UK is to be net zero carbon. Our own target is to be net zero carbon by 2030, which is quite an ambitious target, but it involves going through our existing portfolio and decarbonising our operational emissions, and then going forward, making sure that our new developments are net zero carbon, both in operation and in construction. And 2 examples of that, one I'm going to talk about today, is the Forge at Southwark, which is an innovation-led project that I've been involved with, which I'll talk about in more detail, but essentially using modern methods of construction to minimise the carbon footprint and to transition the building to an all-electric solution that we can secure renewable electrical energy supplies to make it net zero. And similarly with our Timber Square development in Southwark, another building that's probably going to be the next one off the blocks. So the Forge. First, before you get into actually saying you've achieved a net zero carbon building, you need to sort of really understand what framework benchmark you're actually comparing against. There are at the moment 4, 5, 6 different versions of what it means to be net zero carbon. The development of the Forge is a commercial office building, and probably the most furthest advanced definition currently is by UK Green Building Council, and they set up a framework which is all about minimising the energy consumption in a building to minimise its operational emissions as far as possible, moving that then to renewable energy supply, doing the same with any carbon that's used in the construction process, again minimising it as far as you potentially can, but in that instance then using offsets to make the building net zero carbon. The operational energy must align with the Paris proof targets, and at the moment they're still in the process of actually defining energy benchmarks for other building typologies, but fortunately there was one in place for offices. Actually, I talked about these many different versions of the definition. A lot of the people that have created those definitions have now come together to work on a net zero carbon building standard, which I'm actually on one of the working groups for, to try and align all the different definitions that are out there into one that we can all use, which I think will be a great step forward. So the Forge was the first net zero carbon development that met that UK Green Building Council framework definition at the design stage. Basically, we did a whole life carbon assessment at a very early stage and have continuously updated that through the process. As I said, any remaining embodied carbon emissions are going to be, or have actually now been, offset by credits. And we've moved the building to an all-electric building using air source heat pumps, heating and cooling, water-to-water heat pumps for the main hot water generation, and some electrical generation of hot water to complete that. We've got some solar PV on site, and to ensure that we meet the energy performance efficiency levels that are needed, we've used the design for performance process, which is a process on actually looking at the performance and use of the building using sophisticated modelling tools on a process that was developed first in Australia called Neighbours, and there's now been a UK version of that started by the Better Buildings Partnership in conjunction with BRE. So the buildings, there's 2 office buildings on the site. The one you can see in the picture there is the larger of the 2. There's another one just behind that. In terms of thinking about buildings, though, obviously, particularly from a constructional perspective, which I think is the focus today with Buildoffsite, it starts with the extraction of raw materials. Energy is used to create raw materials into building materials. Process of building obviously takes energy before you even get to the final constructed built environment asset. And then there's obviously further investment over the life as those buildings are fitted out and modified, which all involve additional embodied carbon and material use over the life cycle. So it's something that we have to really focus on going forward. I think there's been most of the focus to date has been on operational carbon, but I think going forward, operational carbon is going to be increasingly important. The focus at the Forge was to try and find a methodology that would help us drive efficiency in the use of material, efficiencies in the processes of construction, and efficiency in its operational life cycle. And that led us to look at the manufacturing sector to try and learn from that sector and try and apply it to a building. And you can see in this example here, obviously the car industry radically improved its performance by breaking down their product into lots of individual components, making sure that they're all optimized and brought them together in a systematic way. And the idea for using design for manufacturing assembly, which is what the PDFMA stands about, and a platform solution, something that can be used many times by different people, is the way forward, we think, or one of the ways forward at least, to actually reduce embodied carbon and to increase the efficiency of construction. This is a video that I'm just going to play here that shows some of the research work we did. So good drums there for the time in the morning. But essentially, the idea there was to create a platform solution of the structure, which is the frame for the building. Most products start with a framework of some form, whether it's a chassis for a car, whether it's a back plate for an electronic product, on which then you can put the components of the building. For a building, it's all about the structural frame, the superstructure of the building in terms of providing that chassis, if you like. And also the real intention here is to build that frame as accurately as possible so that other manufactured products can fit onto it on site, as opposed to the traditional method of construction that requires a lot of on-site modification and in turn produces a lot of waste and inefficiency. We estimated that it was almost a 20% reduction in the embodied carbon of the building just on the structural elements that we changed. And we also focused on other elements of the construction components used to actually further reduce that. And we're at 25% plus at the moment, just waiting for the final assessments to come through before we can sort of absolutely say what we managed to achieve. But a major element was that focus on the structural piece, which enabled us, compared to a traditional structural solution using a steel frame, reduce the amount of steelwork by about 18.5%. And by using a ribbed concrete slab in a hybrid steel concrete structure, we were able to reduce the amount of concrete by about 13% as well. And we used a reusable set of temporary works material, which you saw in the video, to actually create the structure, and that essentially starting to look to a circularity of use. We used one set of shutters and two set of props to construct all the upper levels of the building. This is some pictures of the works on site. You can see the propping system as well was a diagonal propping system, which had further advantages of transferring the load from the concrete from the level above while it was reaching its strength directly back to the primary steel frame, so that we didn't have to prop directly off the slab below, which increased the speed of the construction cycle and kept a lot of clear space compared to the usual vertical propping that you would have probably over more than one level for quite a period of time. This enabled us to get access to the level below and to ensure that we could use that material time and time again to construct each slab. We also automated the process of putting up some of the components of that structural solution you saw on the video, using these reach stacker units here, which provide very accurate placing of the material on site. A lot of the bracketry and materials that were used for the temporary works were done by a robot, as you can again see in that picture in the far left corner. We didn't just stop with the structural piece. The big focus was on the three big elements of the building: the M&E services and the cladding. Cladding is the unitized cladding, already a very highly manufactured product, but often the lack of an accurate frame makes it very difficult to achieve the time and efficiency savings that are normally associated with that sort of approach, because a structure is not built to the accuracy really needed. All the M&E for the main mechanical services that went onto the office floors was constructed off-site, which is unusual. You see lots of risers and plant rooms created off-site, but you don't very often see on-site manufacture of the Cat A installations. Here we were able to do that because it was able to be coordinated with the accurate superstructure, which also included fixings embedded in the concrete, which meant that we could actually save a lot of hand drilling on site. About 23,500 fixings were provided and integrated with those services. We're able to do that because we brought on board the subcontractors with a supply design component in their package early onto the scene at stage 3 to stage 4 to work alongside our designers. In terms of reducing the operational carbon, as I said, we use the neighbours design for performance rating approach, and the building's forecast to achieve above 5 stars. 5 stars was the level that was needed to meet the UK Green Building Council framework. We moved away from having gas boilers on site, went to high efficiency air source heat pumps and water source for the hot water. And we already buy our electricity supply for all our buildings from Rego-backed tariffs. We have some self-generation on some of our sites, including this one's got some PV. And in the future, we're looking at the use of CPPAs to further deep green the energy supply to the building. Just a quick picture of the air source heat pumps on the roof in place. Buildings very much in the sort of public eye because of the approach using DFMA. A lot of people have had tours of the building and have seen some of the work that we've done there. As I said, it doesn't just stop with the new projects. The new projects need to be net zero carbon so they don't add to the existing challenge that we have with the buildings that already exist, but we can't just leave the buildings that we have as they are. So moving forward, we're investing in them with a £135 million investment plan, and this will be delivered between now and 2030, enabling us to move all the buildings to an EPC rating of B. Over 40% of our buildings already are at B or above. So we have a good start, but we've still got work to do. In terms of the things that we're going to use to reduce the emissions in the existing portfolio, we're going to improve the BMS performance using AI technology. We're going to invest in air source heat pumps to take out gas burning on site, deploy solar PV, particularly across our retail centres where we have large roof areas, and importantly, engage with our customers to ensure that they operate the buildings in the way that was intended and work with us to drive down energy use wherever possible. We're already making progress on those things. The optimisation of the BMS, the collaboration with customers, decarbonising the air source heat pumps, the first projects should go on site later this year, and a major investment to improve the EPC ratings right across the portfolio. Why does it matter? Well, I think you've heard of some of that before. I'm sure you've probably seen this particular representation of the temperatures of the Earth's surface temperature since 1850 to 2019, and we all know, I think, that in recent times global warming has been accelerating, hence the red towards the right of the screen. This is becoming a physical tipping point in terms of the Earth's climate. We're already seeing lots and lots of natural events and disasters that have been occurring, from flooding to fires, massive financial losses. There's a real requirement for us to invest now for the future. So we can't not do the sort of things that we've been talking about in today's presentation. Our ambition is to be a leader in this space. We were the first property company to set a science-based target, and that's been further updated in line with the Paris COP, from originally a 2-degree science-based target to 1.5 degree, and that's where we're currently targeting at the moment with our investments going forward. There are benefits of net zero carbon buildings. Hopefully that will be aligning with our customers' ESG ambitions, and hopefully that will mean we'll win when it comes to the race to getting customers in our buildings. So it's always good to add value to the business, avoiding long-term problems around asset value and liquidity, and avoiding premature obsolescence and the stranded asset risks. We want to move that electricity supply to renewable energy, as I've described before, avoid any dependence on fossil fuel, and become an engaged partner for our customers. In summary, we're committed to being net zero carbon by 2030, company by 2030, a strategy that we've based around the climate science to identify a pathway, a sustainability leadership position that is recognised beyond our peer group, not just in the property industry. And sustainability means to remain relevant and deliver business value into the long term, and it's important for us to be a sustainable company, as well as delivering sustainable assets for our customers to use in the built environment. And hopefully the lessons learned from the Forge will help us to take that forward into our new projects.
Thank you, Neil. Just to confirm, we've got a hard finish at 12:30, so if we don't get to the Q&A, any questions that have been raised on the system, we will ensure that we respond. So please welcome our final singer. You're not singing today, Ian, but your speaker, Ian Heptonstall, Director at Supply Chain Sustainability School. Ian will share how meeting the Green Revolution targets for the UK enables Offsite to deliver and offer long-term assurances around modern methods of construction. Thank you, Ian.
Thank you very much, Kat. That's great. I think I've got control of the system now, haven't I? So I should just be able to move on with the slide. There we go. Okay. Yes, thank you very much. It's been two really good presentations there. I'm conscious that we want to get some questions in because I see the questions popping up on the screen. So I've kind of slightly shortened the title of our presentation. Can Offsite help us to meet our net zero ambitions? I think that's what we're really talking about today. When we look at those ambitions, sorry. We're looking at those ambitions. In the construction context, delivering our net zero targets mean largely eliminating emissions from domestic and commercial buildings by 2050. That's a big challenge for us. I want to be talking this morning about what does that mean? It means about looking at the whole life carbon of our buildings. And when we're looking at whole life carbon of our buildings, work that's been done by RICS in this, RICS in this area is really useful. We need to be looking at the embodied carbon, which many people have been talking about on the call today, but we also need to be looking at the operational carbon. And I believe that offsite has a role to play in both of those areas, but I think we need to do a lot more as a sector or as a subsector within the industry to show and evidence what we're actually doing, both for operational carbon emissions to reduce them and embodied carbon emissions. You can see there the difference between office, warehouse and residential, but very roughly looking at around 70% is embodied carbon emissions, obviously going to get less over time. And we look at those operational carbon emissions as well. And what can we do through the manufacturing process to help to ensure a reduction in operational carbon emissions going forward? That's something which is, I think we need to be focusing on, as well as the embodied carbon. And you heard from Ian speaking then how important the operation of the building going forward is for their customers and for themselves as an organisation as well. So we talked in the title about lots of targets that the industry was setting. We've seen targets that others have set already in the various case studies. Some of you will be familiar with the London Energy Transformation Initiative, started off back in 2020, said that by 2030, 100% of all buildings will be, new buildings will be carbon zero, which is pretty good going. Some of our speakers have also alluded to the fact that, well, what is a net zero carbon building, and that actual fact that the work done by UK Green Building Council is very informative in this area and helps us to really understand it. But we're moving on from there in terms of trying to understand what net zero rather than bet zero, net zero carbon buildings means going forward. And you can see all those organisations, LETI, UKGBC, RICS and Carbon Trust and others, CIPSI, are all coming together to say we really need a standard which actually sets out what we mean by net zero carbon buildings. Yeah, so they've started that consultation process. If you haven't already engaged in that, I think you've actually got a few days to actually get involved in that consultation process before that closes. From our own organisation's point of view, we've done quite a lot of work trying to understand whole life carbon in construction, and this is some work we've done looking at Barratt's, for example. It's really important for us to understand where that carbon actually applies, and I think for me this diagram really helps us to understand carbon in the built environment. And this is a housing sector, but it doesn't vary that much when, as we saw before, when we look at the other sectors in terms of commercial buildings and public buildings. But you get a very good idea there in terms of how much is raw materials, how much actually was a big surprise to us in terms of ground preparation and foundations and the like. And I noted also that when Mark was talking about net zero carbon, he actually made the fact about above ground. So what happens above ground in their process, what happens below ground is also very important as well. And Graham's earlier presentation about concrete is very informative there as well. But you can see from there that those raw materials that we use is very important for us. That as an industry is where we should be focusing, but also on the carbon that's going to be used through the lifetime of that product as well. So hopefully that says a slide really kind of helps you to understand the work we did with Barratt, to understand actually how do you report data, how do you find that data out from supply chains. We did a little bit more work in my business as well, trying to understand what are traditional house builders and traditional main contractors doing. And there's a lot of detail on here, but in effect on the left hand side, organizations were making a public commitment to reduce carbon, but then we try to go through and actually have a look at what did that actually mean in reality. What were they actually asking to? And what was interesting there is the number of organizations who were actually including supply chain scope 3 in those targets. There's a lot of red crosses in there where they weren't including supply chain scope 3, and even less organizations who were looking at what you might call downstream scope 3 carbon. Downstream, that's in effect the operational carbon of the building itself. To get a science-based target initiative, you need to include both your upstream, i.e. your supply chain, and your downstream scope 3. So we've got a lot of work to do with some of the major organisations, main house builders and main contractors, if they're really serious about tackling the scope 3 and getting to that net zero situation. A lot of detail in that. I don't intend to spend ages on that. But I'll just now focus a little bit on embodied carbon, and thanks very much to HTA Design here, for example, who setting out, many of you are familiar with the volumetric work which was done on George Street, for example. Letty set out those benchmarks for where we should be at 2020, 2025, and in 2030 in terms of the amount of CO2 per square meter. And you can see there in terms of George Street where that's actually got to in terms of its performance. I think that's a really good place to see what the potential for our industry has to offer. But I would also flag up as well that when organizations look at this data, you've got to be careful about where that data actually comes from. Because when we're looking at embodied carbon data, some organizations use spend data, some organizations use proxy data, and some organizations use actual data. What do I mean by proxy data? For example, you might well see the example, like the last example we saw where in actual fact what was happening, we knew how many tons of steel were used, how many tons of glass were used, how many tons of the various materials which you use in the construction. But we actually the calculation used proxy data because it was taken from the ICE database of embodied carbon in materials. It wasn't actually taken from the actual data from the materials which were bought, and that's where we need to get to as an industry. Because from my experience, when we're looking at carbon, we need to be looking at the ability to design out carbon and also to procure out carbon as well. But to do that, we need actual data. Actual data can come from the materials or actually the supplier. So what is the carbon footprint of your supply chain? What is the carbon footprint of the actual materials that you're actually using? So I think that's important for us to look at that. So methodologies to calculate scope 3, we can use spend analysis, which gives you a really good starting point. It's very approximative and very limited use, because actually as you make different decisions, unless you actually spend less, it doesn't actually make any difference at all if you optioneer between one type of concrete and another, for example. You can use site or contract specific data, or you can actually use an apportionment methodology, which helps you, especially if you're using a series of suppliers which you're using on a regular basis, and you're looking to for those suppliers to actually reduce their carbon going forward. In the supply chain school, we've got literally hundreds of partner organizations who are grappling with this point about their scope 3 emissions. So we developed something called the Carbon Calculator, and the Carbon Calculator is basically a digital platform which enables major contractors and house builders to ask their suppliers what their carbon footprints are, and for them to report that in one place, and that one place, that data is then shared amongst all of their clients. We launched this back in August 21. We now have 1,500 suppliers registered, and we've had 531 suppliers actually report their carbon through this. So this is actual carbon data being reported. And what we're looking for is actually to get obviously up to the 1,500 of those suppliers to report their carbon on an annual basis. But we want year-on-year reporting those carbon to find out if the key suppliers that we're using in this industry are actually reducing their carbon footprints or not. So the Carbon Calculator is a freely available tool that we've said to actually use. Anybody on the call now can use that. Go to Supply Chain School, you can find links to it. You can use it to calculate your own carbon footprint. And if you're supplying into any of the key contractors or house builders, you can actually apportion the amount of carbon in your supply in your organization into those key suppliers and key customers of yours. Quite a lot of functionality involved in the Carbon Calculator. It gives you lots of different types of reports, frequency reporting, apportionment data, data visualization. If you want to get all the data on your suppliers, there is a fee associated with that, but I think you'll find it's a very reasonable fee. So that's how to look at the upstream data. That's looking about what embodied carbon is in your supply chain. We also need to look at the operational carbon, and using the RICS whole life carbon assessment here, we've already established that 31% to 39%, depending on whose methodology you look at, is it actually the carbon in use. The challenge for us in the offsite industry is how can we reduce the operational carbon of a building. If we're building better, if we're building modules which perform better and perform as they're designed, unlike traditional building, we should be able to significantly reduce that. But whilst I've seen ad hoc surveys, I don't see the actual evidence base. So one of the things my colleagues are actually doing is that we're actually making a call for evidence right at the moment. Nigel and others on the call today are involved in that. We're making a call for evidence to actually see what evidence exists in there in terms of whole life carbon in the embodied stage and actually in the operational stage. So if we're building, if we're using offsite and modern methods of construction to build better, Are those buildings performing as designed, and are they performing better than traditional build? We need to get the evidence base to do that, and I'd like to invite you all to get involved in that process that we're actually doing at the moment. And as you can see there, we're hoping to produce some guidance documents by the end of March next year. So that's me finished, and again, very whirlwind. So in summary, I'd say if you're interested in calculating the carbon of your own organization or your supply chain, go and have a look at the carbon calculator. If you're interested in helping us to understand how the offsite industry and MMC can actually improve the performance of the built environment going forward, please get involved in the study that we're doing at the moment. My colleague Naomi is doing. Thank you very much for your time, and back to you, Kat.
Thank you, Ian. Again, a huge amount of information in there for our attendees to absorb outside this webinar. If I can invite all of our speakers to put on their cameras. We probably have time for maybe 2 or 3 questions before we go to the summary and closing out. So I just want to cover some of the questions that have been raised in the chat. And the first one is for yourself, Graham. And how does CPRO protect against corrosion?
Well, there are multiple methods of doing it. As a company, we produced the anode binder, so it's unusual to find an anode for protection that is actually a mortar or a concrete or the cement that's used to do that. So that's where it's novel. But essentially, what we're doing is to use that anode to pass a small extra low voltage electricity supply to provide the electrons to the steel to prevent them from corroding. And you can do that in multiple methods. Being a binder, you can drill it in, you can spray it on, you can cut it into concrete, or in the case of the video that we showed, a componentized modular molded form of it that can be attached straight to the reinforcement steel prior to construction. So different methods of getting the anode in position. Once the anode is in position and wired, it comes to an external power supply. That power supply then provides the current, and it's monitored using embedded sensors. At CPRO, we use corrosion rate sensors because that allows us to develop the data to a cumulative figure, which allows us to do service life tracking. So we're not only looking at the long-term benefits of the system to the structure, but also how the system itself is holy and switch on from day one and prevent corrosion from happening.
But I think it just highlights the importance of that designing in the right way, but having that evaluation and monitoring, which is ongoing, and taking that whole life approach in all the things that we do.
Absolutely.
So just picking up on another question that's come up, in terms of when we're talking about whole life and we're talking about net zero, it does take carbon offsets into consideration. And this is a question for yourself, Neil. And I know you touched on it in terms of your presentation, that you are still working through the data, but what's the expected carbon offset for the forge? And what type of selection criteria do you apply when offsetting to guarantee their quality?
We've got a useful comparison because we did design the building originally to be delivered traditionally. So we've been able to benchmark ourselves against a counterfactual model effectively. So we've reduced what would have been the original carbon footprint of the building by about between 25 and 30%, of which nearly 20% of that came from that structural, novel structural hybrid solution, that the DFMA chassis for the building. The remaining carbon will be offset using gold standard certified carbon offsets, and those calculations are being finalised with our sustainability team at the moment. So, and they'll all be published later when we've got the final details.
And just picked up on that, Neil, and I think it's also a question for Mark as well. In terms of when you're looking at your whole life performance and the life of your asset and monitoring your net zero performance, are you going beyond the completion of that asset? How are you ensuring that in terms of the offset that you are keeping track of, that it's performing as it's expected to do? How does that work in terms of your projects?
Shall I go first, Neil? And just to, yeah, I mean, any project that we deliver, we work with AESG to continue the monitoring and also support the client in their use of the building. I think there are, you know, in the past, a lot of manufacturers like ourselves would have delivered the building for either tier ones or for themselves and walked away. Now there's a greater emphasis on actually keeping that collaboration, ensuring that the end user uses that building correctly and to the most efficient way possible. And we back that up by monitoring their use, both any PVs or any mechanical electrical items that are in there, and then going back periodically just to sort of give them an update and say, look, you know, this is how you could be using it better, or monitoring if any of the systems are not operating at full capacity, going back and within the 12-month warranty period, replacing them and making them as efficient as possible. So the partnership now extends way beyond handover, and we see that as part of our role.
So in terms of our buildings, obviously we build for our own portfolio. So we manage the buildings that are multi-occupied ourselves. So we're responsible for procuring the energy for the operational side of the buildings. And we, as I've said, we procure REGO-backed electrical supplies, which are all from renewable sources. The key is to reduce the actual energy use ahead of gaining the renewable energy to supply it with, so that you minimize the amount of energy that you're using as well, because obviously there's a finite supply in the marketplace of fully renewable electrical supplies. So that's what we do in terms of making sure that our operational carbon is minimized or eliminated effectively from our portfolio. In terms of the constructional carbon, that's obviously offset at the point when we finish the construction process. And after that, it is about the interventions that are done by occupiers and the fit out of the building, or if we make any modifications in the future, and then we would have to return to look at what we would need to do then to minimise the embodied carbon that's used, and again offset any residual carbon through its lifetime. But our focus at the moment is that initial build, which is the bit we have full control over, and then operationally ensuring we run the buildings efficiently, and then offsetting, actually securing renewable supplies.
Super. And I think in a way we've all talked around, or you've all talked around in terms of that more of a systems-based approach, in terms that actually everything is interconnected, but it's still part of the granular detail that gives us the answers. And one question that's come up, Ian, is around the supply chain school and whether they've ever compared their carbon calculator to those of other organisations. Because as you say, different organisations have different calculators, sometimes they're not aligned, they use different data. So have you looked at in terms of other organisations such as the Environment Agency or other consultants?
Absolutely, Environment Agency are one of our partners, and they're involved in when we're developing it. We're very much aware that actually the tool that we've created is actually a very much a basic tool, a stepping stone for people starting out on their journey. Why did we develop it? We developed it because, to be frank, I just got frustrated by the fact that we were going out to our members who were learning about carbon and were learning about being more sustainable. But when we asked them, are you reducing your carbon, yes or no? The biggest answer was, we don't know, because they weren't actually calculating their carbon emissions. They didn't know what their baseline is. They didn't know what their performance this year is. So we created a tool just to find, give them the ability to actually calculate their carbon. There are other tools out there that just happen to be ones that they would trust. But what we wanted to do, though, was to create a tool that our partner organisations who pay for the school could actually pull that data directly from the members, and the members could just report it once. Because the thing that we find from our supply chain members is what annoys them most is having to report the same thing multiple times to the same customer, to different customers. It just drives them bonkers, and it's fundamentally inefficient as well. Having said all that, we absolutely know that on larger projects which can afford to do all the full carbon calculations around their embodied materials and the like, there is a budget available for people to do the type of work that Neil's done. And I would never want to go away from that, because those exemplar projects which can afford to do that and are doing the right thing lead the way and provide case studies for us all to learn in other areas. But fundamentally, what we're looking to do with our carbon calculator is looking at the emissions from the supply chain, because when main contractors and house builders have signed up to science-based targets, one of the key things they need to understand is what is, of their supply chain, what are the carbon emissions? Are those suppliers that they're using year in, year out actually reducing their carbon or not? And that's what our tool does.
Super. Now, we're not going to be able to get on to the other questions, but you got your hand up there, Mark. Is it a very quick one before we do a sum up and closing remarks?
Sorry, it was a misfire by me. I was taking out the chat and I must have pushed it by mistake. But great presentations by everybody. I've really enjoyed it.
I was just going to quickly pick up. There was a couple of questions around setting benchmarks. I think part of the net zero carbon building standard work that was referred to, I think, by Ian, is intended to actually coalesce and set benchmarks for all building typologies for both operational and embodied carbon. Quite an undertaking, and the hope is to have it all done by the end of next year and initial data out early in the year. So a lot of work to be done, but it's obviously really needed to help people target things. Our original targets were based around measuring our carbon footprint for embodied carbon and then trying to reduce it by at least 15%. We've done more than twice that level with the modern methods of construction. Going forward, we're going to set absolute targets, and I think it's still being worked through, but provisionally, I think we've looked at some of the LETI targets, and I think around the 600 kilograms per carbons per square metre is sort of a good target to aim for 2030. But this is also going to be a moving target, and I would wait until next year until you see those early benchmarks coming out to see what we've managed to come up with between us. There's a lot of people involved, and again, I'd reinforce the ask. There is a call for evidence to anybody that's got information, great case studies or databases that they want to share. Then let us have them so that we can analyse what's going on now and what the best case samples are. In terms of our reporting, we also report annually anyway as part of our reporting cycle on energy consumption, and we've been monitoring and targeting energy consumptions now for about 4 or 5 decades to drive energy efficiency in our buildings. So it's not a new thing for us, but it is for some people, and what we need is everybody to get on the journey.
Okay, so I'm going to pause you there, and Ian, I know you got your hand up, but if you've got anything to say, if you can put it in the chat for our attendees. Very quickly, 30 seconds, Andy, in terms of a whistle-stop tour, in terms of some of the key messages. I think some of the things that we talked about in terms of what it takes to build really does require a collective vision across industry, and it can't be done in isolation. And it really does need to be values-driven and purpose-driven, and that's from individual projects through to the organisations who are committed to addressing climate change. We have to take a whole life approach in all the things that we do, but understand that there are additional co-benefits that we really need to draw out of that. We need to look at the permanent, but also the temporary works. And I was very interested to see some of the things that Mark was raising. But it really is about the component parts of design, operation, maintenance, decommissioning. It's about making the right decisions and understand that carbon is linked to all aspects about what we do. And it's about the granular detail. So it's not just about forecasting things and estimating, it's about the data and evidence that goes through that. It's being able to take the granular detail and make decisive actions to make a change. As a construction industry, and the organisations and the projects that we deliver and the whole life assets that we look at, we need transformational and contingent improvement across the construction sector. So there's lots of stuff in there. I think we're all supported in terms of the great guidance that comes out and the different standards, but to be moving those forwards, we need the data and evidence to keep testing those assumptions. There's been a call for different levels of evidence, but we'll make sure that we include that in the summary in terms of actually how you can link into those different things as well. Over to you, Andy.
Yes, thank you very much, Kat. I just wanted to take the opportunity to extend my thanks both to today's speakers and also to Kat for chairing an absolute wealth of information within that. So thank you very much. The presentations and the recording will be made available to you post-event. We will also send out a survey. We would welcome your honest feedback, including trying to squeeze 4 really good speakers into an hour and a half. So please feel free. I just wanted to flag the upcoming webinars in this series, and it really starts to explore some of the things that Ian talked about towards the end around carbon tracking and calculating, which is earmarked for February 23. We can maybe have a little bit more of a deep dive into some of that. and also the low carbon concrete sort of route map and the next steps in terms of the concrete decarbonisation task force, which is sort of multifarious in terms of its various work streams. We hope to be able to present something which begins to draw some of that together. Thank you very much to all of our participants. I recognise that being online is not as easy as in person, but thank you for your questions. For those questions that are remaining, we will ask our panelists just to put a few bullets together. But thank you very much for your participation, and I hope you enjoyed it. Please feel free to give your feedback through the survey. Thank you very much, everybody. Bye for now.
Thank you. Goodbye.